Here we are in the Claude Desktop interface. We're about to demonstrate the Text2Sim Model Context Protocol Server, a powerful tool integrated with Claude. We're starting by pasting in a natural language prompt. This prompt describes a complex scenario, simulating passenger flow through a mid-sized airport, including check-in, security, and boarding stages. Notice the details in the prompt. Specific passenger arrival rates, processing times for check-in using a uniform distribution, security times following a normal distribution with standard deviation, potential boarding stalls using an exponential distribution, and the number of resources like counters, officers, and gates. We're asking for a 12-hour simulation. Let's send this to Claude. Claude understands the request involves simulation and prepares to use the integrated Text2Sim tool. It shows that it's running Simulate-Des via the Text2Sim MCP Server, which is running locally. It starts by constructing the configuration based on our text description. Because Text2Sim is an external tool, Claude prompts for permission to run it. We'll click Allow Once to grant permission for this specific interaction. With permission granted, the Text2Sim MCP server now executes the Discrete-Event simulation using its SimPy-based engine in the background. Claude receives the results and begins to format the output. Claude first summarizes the simulation parameters it used, confirming the total time, arrival rate, and expected number of passengers. It then clearly outlines the processing steps as defined. Check-in, with its capacity and uniform processing time. Security, detailing its capacity and normal distribution for processing time. And finally, boarding, with its gates and exponential distribution for potential delays. This confirms the model accurately reflects our request. Now we get to the core results, the key metrics derived from the simulation. Claude presents the average wait time, throughput per hour, and resource utilization for each stage, check-in, security, and boarding. Based on these metrics, Claude automatically generates observations. It correctly identifies the security stage as having the highest utilization, suggesting it's a potential bottleneck. It also notes the queuing levels at each stage. Furthermore, it provides actionable potential recommendations, such as considering adding another security lane or optimizing processes, directly stemming from the simulation insights. And there you have it. Within seconds, we went from a complex, natural language description of an airport workflow to a fully executed discrete event simulation, complete with key performance metrics, observations, and recommendations, all facilitated by the Text2Sim MCP server integrated seamlessly into Claude. This highlights the power of combining LLMs with specialized tools for complex analysis.